we're going to start with the yellow sheet. Going over 5-3 formulas that you need to know. You should have these as well on your yellow sheet. The yellow sheet needs to have everything on it. Otherwise, you're going to be SOL for the test because you can use this on your test. So we're going to finish filling this out. These 2 rows here, block out 2 rows for the Poisson distribution. And then we're going to go over the, review, the remaining problems that we did not already fill out yesterday. Okay? And we'll be done.
What does SOL stand for?
I have no idea. Poisson distribution. Poisson distribution. Looks like poison, but it's not. The Poisson distribution has no upper limit. I've talked about that before. No upper limit or no N, really. No upper limit or no N, okay? They'll just give you an average. Average instead. So instead of saying, I want to know the chances of 3 out of the 14 people passing this test, they'll just say the average number of people that pass the test is this, right? They won't give you an N, okay? So average instead. They will give you a mu, yes, okay? So they won't give you an N, they will give you a mu, okay? They're going to ask the same questions. They're going to ask for probability, just like they did in binomial. But the information that they gives you tells you that you're going to use this rather than the binomial formula, okay? So the wording is going to be similar, like find the probability. Okay, great. Write down what you have. Do you have N's and P's and R's and Q's? If you do, you're going to do the binomial. If you don't and you just have averages and that type of thing, you're going to use the Poisson distribution, okay? Poisson distribution, I got to look at it because I don't have it memorized. P of X, here we go. Write this down. P of X equals, you got some stuff on the top and some stuff on the bottom. Let me go back. I'll zoom in. Mu to the R times e to the negative mu all over R factorial. Make sure you write that down correctly. I had one person last year, I know for sure, write that down incorrectly. They might have put a minus sign here. I don't remember, but it screwed everything up. Okay? I don't know. Caleb sounds appropriate, yes. I think maybe it was Caleb. I don't remember who it was, but that sounds like a Caleb thing. Yeah. So make sure you write that formula down correctly.
No.
All right?
Oh no! I just spilled water on my face.
Okay. All right. Mu. What's mu? Average. Okay. Now, how do you calculate the average? If they don't already give it to you. Okay.
Exactly.
I only wrote one note.
You take n times p, or you might need to divide. And I'll talk about more of that here in a second. So you either take n times p, the number total, times the probability of that happening, and then that will give you the average times that it happens, or you're going to divide, and I'll show you an example of divide here in a second, okay? So that is mu. What is R?
The max or whatever.
R is the number of times that you're choosing, okay? So I'm just going to say number choosing. Like, if the average is 7 hurricanes a year, what's the chances that I only have 6 this year? 6 would be your R, right? It's the number that you're specifically choosing that you're looking at, okay? What does E stand for?
A number.
It's a number that's in your calculator, okay? So it's not a variable that you plug into. So you really only have 2 pieces of information for Poisson distribution. That's it, okay? Now, also, I'm going to draw a line because we have a mu that we've already talked about, so average, but then we have the standard deviation. And then we have, we're just going to do mu and standard deviation for that, okay? For the Poisson distribution, the way that it's set up, to find the standard deviation, all you do is take the square root of the average, right? Okay, on 5-3, they had you find the standard deviation, right? They give you the average. They say find the standard deviation. Great, you take the square root, okay? Then they asked a really funny question, which was find the variance. Okay? How do you find the variance if you're given the standard deviation?
It's the mu.
Right? Like this is the square of that, right? So I'm literally taking the square root of mu squared, which is just the average. So these 2 numbers will be the same, right? Your average and your standard and your variance will be the same number for Poisson distribution. Okay? The way that it is designed and set up to be that way. Okay? All right, ready for example? All right, here's your example. I got to look at my numbers. Last year, Hastings, Hospital, Mary Lanning. Hastings had, I don't remember. Let me look at the number. 1248. 1248 babies born. I'm just making these numbers up. Okay, there were 1248 babies born last year. Okay, find the probability. Find the probability of 5 babies born in a day.
Oh my gosh.
Okay, so what are the chances that 5 were born in one day if 1248 were born in one whole year? Okay. All right, so I'm going to pick apart some information, and we're going to put it off to the side over here. So they're not giving me like they're not giving me P's and Q's and stuff in here. This is not binomial, okay? So we have to find the mu. We have to find the average, okay? So how do I find average?
Put them away.
1248 is the number that it gives me, but that's per year. 1248 was over the entire year, and I want to know for just the day.
Divided by 360.
I'm going to divide by 365. Okay, so do you guys know when I wrote down here to find the average, you may need to divide? That's what I was talking about, okay? So like dividing, we took 1248 divided by 365. So on average, if that's how many? 3.42 babies born per year, or per day, on average, right? 3.42 babies born per day. Okay, so I want to know what the chances are that 5 were born. Now, does that seem like astronomically high? Like there's not a very good chance of that happening?
No.
There's probably a good chance that 5 are born in a day if the average is 3.42. Okay? So we talked about this yesterday. This probability is probably not going to be like 0.000001. It's probably going to be a high probability, right? Like a high chance that 5 are born in a day, okay? All right, so what is 5 though? What variable do we assign 5? That's our R. R is 5. Okay? R is 5.
Okay, so
Okay, so
3.42
P of X equals, let's plop into the formula.
to the 5.
Mu 3.42 to the 5th
3.42
times.
all over 5 factorial.
Perfect. I would strongly suggest finding a calculator and plugging that in so that you can get an answer. And since it's a probability, it should be a number less than 1. We know it should be a decimal, right? 0 point something. All right? 1275. 0.1275. Okay, so we're going to write out what that means here in a second. 0.1275. That's what you should have gotten. If you did not, you didn't type it in right. Because I know that that's the correct answer. Shh. 0.1275. Okay, what does that mean?
12% chance, 12.75% chance that 5 babies will be born in one day.
Chance of 5 babies
Schwaney, stop touching me.
in one day.
If you write penis on me,
Hey, shh. 12.75% chance of 5 babies in one day. There you go. Okay, let's do also, we know that the average was 3.42. Okay, standard deviation.
Square root of that.
Square root of 3.42. 1.85, sure. Okay. All right, that should do it. That should do it for stuff on your yellow sheet. I'm not going to ask you variance, but just FYI, variance
That
would
is
be
variance.
Variance is
Sigma
sigma squared.
So the mu.
Is it sigma?
What is sigma?
Sigma is standard deviation. Sigma squared is the variance. Because you take the square root of the variance to get the standard deviation.
Is average. Is the same thing.
What? Which one's variance?
Sierra.
This is standard deviation.
One of those
Well,
trees.
is it called sigma or
My
sigma?
backpack.
Standard deviation.
The Christmas
This,
the little
this is
Yeah,
variance.
make me.
Okay.
Okay, perfect. Good? Happy with that?
Not possible.
Yeah, not too bad. Let me make sure I got everything.
The broad guy.
Yeah.
The guy that broad's jumping.
Ligma.
Okay. Yep, we got it all. We're good.
I can't believe
Okay. All right, go back to the review.
I don't even know what that means.
Back to the review. We did. If you were not here yesterday and have not watched the video yet, we did 1 and 2 and 4 and 5
Yep.
Hold on,
and
go back to that.
6
Can you go back up?
and 10 and 14 and 15. We did those yesterday. So go back and watch those. I'm not going to go through them again. Go back and watch those. We're going to do the remaining ones today, just in order. We'll do 3 first. And there we go. Good?
Yeah.
Okay.
Actually,
I am actually ahead of the game. All right. In a certain town, okay? The hardest thing on here is you're getting to a problem and you're like, which formula do I use? I just start pulling out information and looking what you have to see and then going back to find the formula. Okay, so that's what we're going to do. In a certain town, 22% of voters favor a given ballot measure. What's 22% going to be? Probably a P, right? Okay, let's see. Probably P. P is 0.22. 4 groups of 21 voters. What's 21?
R.
9 plus 10.
N.
N, that sounds like a total number. 21 voters total. Find the variance. Okay. Find the variance. Question mark. Who favor the measure?
Square root of the average.
Okay, so.
NPQ.
Yeah. So we have a formula that says to find the average, it's N times P, right? To find the standard deviation, it's the square root of NPQ. This is on binomial. Find it on your sheet. Locate it on your sheet, okay? Which means that the sigma, or the sigma squared, the variance would just be NPQ, because if you square that, then it's gone, right? So we're looking for variance, which is just NPQ. Yeah?
Yep.
Does this make sense? Okay?
But okay.
All right. N is 21. P is 0.22. What's Q?
0.78.
0.78. Multiply them.
No.
How do you know that? Yeah.
What?
Because you take 1 minus 0.2.
22%. 22% and 78%. Right? Yeah? Q?
3.60.
3.60 is your standard deviation? Or your variance, I mean?
Yeah.
Yep.
3.60.
Okay. Perfect.
Hold up.
Wait,
Hold
what's
up.
our R?
You don't have an R. We don't need an R. Because we're not doing the whole binomial thing. We're just finding the variance.
For me.
You got a what?
Can I scroll what?
Never mind. I'll just watch the video.
Okay.
How would that work?
7.
Okay. Good. Happy with that?
No. What is the answer?
3.60.
Go to the formula. We're only finding that.
They're only finding the variance. That's all it asks. Find the variance for the number of people who measure. Find the variance. Okay.
You're going so fast for the first time I'm learning this.
Okay. Shouldn't be the first time you're learning it. Whatever. They got lots of work to do. All right. 7. All right. Here we go. 7. Mars Incorporated. Boys, listen.
Sword fight.
Boys, listen. Mars Incorporated claims that 20% of its M&M plain candies are orange. We're gonna test this theory, like right after Christmas break, possibly. Okay. What's 20%? 20% orange. P. That sounds like a P.
Oh.
0.2.
So
0.2 sounds like a P. So that's representing orange. Q then would be
0.8.
0.8. That would be non-orange. 80% are non-orange. Boys, you're gonna fail this test. Listen and get it done.
100.
A sample of 100 candies. N equals 100. Great. Is randomly selected. Find the mean number and standard deviation for the number of orange candies. So mean is the average.
PQ.
Okay, if 20% are orange and we have 100 candies, how many are going to be orange? You take N times P, 100 times 0.2, which is 20 orange candies. That's the average, yeah? That should just make sense, okay? Standard deviation is sigma. It's the square root of NPQ,
4.
all right? So the square root of 100 times 0.2 times 0.8.
4.
Okay, it's 4, exactly?
Yep.
I believe you, because 0.2 times 0.8 is 0.16 times 100 is 16.
Yep.
You betcha.
And that's it.
Okay, so out of 100, okay, do this math in your head. Ready? Since those numbers came out nicely.
Alright, bet.
Out of 100 candies,
Okay.
what is considered to be a significantly large amount of orange candies?
95.
500.
95.
No.
95.
30.
28.
You're close.
28.
28. Why?
Because two standard
Two
deviations.
standard deviations. You add this twice. What's a significantly low number of orange candies?
12.
So you could crab at the candy company if you have less than 12 oranges or more than 28 oranges. Does that make sense?
Okay, they're not gonna do
Okay.
anything though.
Well, they're not going to do anything. But if that's what they're claiming, you could
Mrs.
sue,
Office will Karen
technically.
the heck out of them.
right? Okay.
Ew.
All right. Good.
Oh, my
Yes. Yes. Perfect. Okay.
It's
All right.
somebody's good
The
job.
accompanying table. Okay. When it has a table, listen. When it has a table and they're asking for mean, go to your yellow sheet, look at the ones that have a table, which is section 5.1. This is where we're at.
Shut up.
We're finding the mean for this, okay? How do you find mean? How do you find the average? When you're given a table.
The sum of x times p of x.
Okay, so I do x times p of x. What's 1 times 0.14?
0.14.
0.14. What's 2 times 0.16?
0.32.
What's 3 times 0.12?
X
0.36. 4
Or
times
minus.
x times p of x. You're multiplying those all the way across, okay?
Too bad it's fake.
0.56.
65.
0.65.
1.86.
1.86.
I wish I was
That's
6'5".
wait.
And then you just add them.
X times p of x. And then we do the sum of them. And that gives me the
Wait.
average. That gives me the average.
Add those up, Marcus.
It is.
And-
3.89.
okay. Okay. What?
3.89.
3.89.
5,
That's
6.
the average, but that doesn't make any sense.
Okay, hold on. Okay,
Why don't we divide
we're
that?
talking about when a dice is rolled, okay?
Oh, just kidding.
Right?
No, you're right.
Dice is rolled 1 through 6, right? And if we average those together, 3.89, like that means that our 4s, 5s, and 6s were rolled more frequently because 3.89 is on the high end of 3, right? Okay? So our 4, 5s, and 6s were rolled more frequently. Okay? Make sense? Ish? Okay, find the mean. That's the mean. Okay?
So that's this thingy?
That's this thingy.
No.
That's the sum of all the x minus
so
p of
what would
x's.
dividing
that's
by
new?
6 give
Wait.
us? Like the average probability?
Wait. But I thought we had to multiply.
No, you wouldn't want to divide it by 6. To find the mean, mu is equal to the sum of all the x's times the p of x's. Okay? So we did a column that was x times p of x, multiplied those together, and then we summed them at the end. That's it.
So
That's
do
the
you have to
average.
take the-
No, that's the average. That's already the average. That's already the average. Okay? Sum is easy. It's not bad. Okay? Moving on to number 9. We got to keep moving, guys, because we have like 20 minutes left.
Yes, crew.
Number 9.
In a Gallup poll, randomly selected students,
66% said they worried about identity theft. What's 66? Probably a P. 66%. For a group of 10, 13. That sounds like an N. Find the mean who do not worry about identity theft. Okay, hold on.
So we need to find Q.
So we need to actually find Q and then multiply, right?
0.34.
0.34. Okay, so average normally is N times P. But if I do N times P, that would be who does worry about it.
N times Q.
I want to do N times Q, who does not worry about it. Right? So just change it a little bit. 10, 13 times 0.34.
344.42.
Okay, 344.42 or 344 average people. I don't care if you round it or if you leave it. For a group of that many people, find the average number who do not worry about identity theft. That many people. Okay? Now, you could have taken N times P, gotten that number, and then subtracted it from 1013. That would work as well. So however you want to think about it, it doesn't matter. Okay?
Number 11.
344.42. Happy with that? Okay, here we go. Suppose the weight of adolescents is being studied by a health organization and the accompanying table describes the probability for 3 randomly selected adolescents, where X is the number who are considered morbidly obese. Okay, ready? This is how this table is broken down. So they have taken a sample of 3. My total number is 3. The chances that none of them out of the 3 are morbidly obese is 11%.
Okay.
The chances that exactly one of them is obese and the other 2 are not is 21%.
Yep.
The chances that exactly 2 of them is obese and one of them is not is 45%.
Yep.
And the chance that all 3 of them out of the 3 are obese is 22%.
Yes. That's bad.
That's bad. Okay, this is happening with the most frequency. 2 out of 3 being obese, that's still a majority.
Mm-hmm.
Yikes. Okay, anyway.
This is
All right.
America.
They're going to ask us some questions. Is it significant to have no obese subjects among 3 randomly selected adults?
No.
Yes.
Okay, what's the chances of no obese?
Your mom.
What is the probability of no obese?
11%.
0.111. Is that significant?
No.
No. Why not?
Because it has to be less than 5.
Not less than 5%. It's 11%. It would be significantly rare if it was less than 11%. Okay, so it's not completely rare that none of them are obese, which makes me feel a little bit better. But, whatever. Right?
What makes you feel better?
It makes me
So
feel
that-
better
is
that
that
it is
all?
not rare to have a
all?
group of 3 kids and have none of them morbidly obese, right?
Is that
It's
all?
not significantly
That's
rare. That's it. That's all they were asking. Just analyze the data.
Right.
Okay? All right, this one, standard deviation. Okay, standard deviation, we just found the average. The average was, I'm going to write it down, you don't have to, but the average was the sum of all the, actually you should write it down because we have to find it. X times the P of X's, right? This one's going to be a longer problem. Okay, this one's going to be a little bit longer of a problem. Okay?
So 0.
Then we have to find the standard deviation. What's the formula for standard deviation? Somebody give it to me. I don't know.
Square root of MPQ.
No.
Objection.
No.
We
It's a
don't. We
sum
only have
of-
a variance one.
It's the sum
Of all the
n
X.
minus X.
How do you know that?
Facts.
Because we
Wait.
wrote it
X
down.
minus-
It was
X minus mu's.
n minus X squared.
How do I know which one to look at?
N
Yeah,
minus
it's first
X.
mu.
Oh, mu minus
Yeah,
X squared.
sorry.
Got it. Okay,
Next
I'm
one.
confused. Mu minus X's. Got it.
P of X.
Squared times P of X.
I'm sorry. I thought that was the variance equation.
No, this is
Oh.
oh.
That is
This
Yeah,
is
yeah,
the
yeah,
variance.
correct.
And then you take the square root of that. Yes, you're correct.
Oh.
Square root of that number.
Confusing.
Okay, all right, so this is going to be the one that you really need to pay attention on because these standard deviation problems, when you have a table, there's a lot of room for error on here.
That's
These
comforting.
are huge.
Basically, that's
These are huge. No, they're fine.
But yes.
They're just put yes, right? Okay. So the first thing we have to do is find the
sum.
No, the average.
the average because we need to know mu. Mu has to go down here in this formula.
Not the same as
Okay. The average is going to be different. Okay. So all right, here we go. Question. This is what finding the average means. Out of 3 students, what's the average number of children I would have be obese? Right? What's the average number of children you have be obese? If 45% are obese, I'm going to guess probably between 2 and 3 is going to be my average, right? Because those are the highest percentages. So I'm going to guess my average lives somewhere in there, maybe like 2.2 or something like that, right?
1.78.
Is it really? Hey, okay.
1.77.
All right.
Explain.
All right, let's find the average. How do you find the average? X times the P of X. Okay, so we're going to multiply all these across. 0 times this.
0.
0. 1 times this.
215.
0.215. 2 times this.
Right.
0.9. 3 times this.
0.672.
Okay, now I
Add.
add them all together. That gives me mu.
1.787.
Okay, 1.787. That is my average. Okay, all right. So that's a little less than 2. Whatever. Okay, that's the average number of children out of 3 that would be morbidly obese. Okay. Now I'm going to find the standard deviation. This is the hard part. Okay, I have to take all the x minus, or no, excuse me, wrong. Mu's minus the x's. I'm going to square them, and I'm going to take it times p of x. Okay, I'm going to write all the work out for each one of these.
What?
Okay, you ready? What's mu?
Oh my god.
Average.
1.787 minus, what's my first x? 0. Okay, I'm going to take that and I'm going to square it. And I'm going to take that number times 0.111 because that's p of x, okay? Then I'm going to take 1.787 and I'm going to subtract 1. And I'm going to square it. And I'm going to take that one times 0.215. Okay, then I'm going to take 1.787
-2.
minus 2 squared times
0.45.
0.45. Then I'm going to take 1.787. It's not a hard process. You just have to keep doing it over and over again. Right? Times 0.224. Okay, we're going to get each one of these numbers. I'm running out of room, so I get to do this. Sorry, guys. I win.
Where the heck do we get 0.45?
Okay, because that's what the PRX
Oh.
is. Okay? All right, these are not the answers. I haven't got the answers yet. Okay? All right, I'm gonna wait till you guys all get them, and then we'll check and see who, whatever. Wouldn't be a bad idea to practice typing one of these or multiple ones of these in.
This is so stupid. I don't
Do you want the answers?
Do you
Just
have the
wait,
answers?
Just wait, chill.
Just wait, chill, she says.
What do you want me to just?
I want you to sit and twiddle your thumbs.
For just a dang second, Marcus.
Sorry.
Dang nabbit, why did I do that?
The first one is not 0.
No, the first one's not 0.
Why?
Because 1
Because
minus
1
0
minus 0
squared.
squared. Yeah,
You're
that's
right.
not 0.
You're right.
I know I'm right. Thank you, Marcus.
This is going to be the long problem. The rest of them have been pretty darn
Do we
short
have
so
one
far.
of these tomorrow?
Yes.
Hey.
I give
Oh.
you one standard deviation one.
Are these, is the test gonna be like this?
Probs.
It's like
But not as many questions.
Well, yeah, and it's scared.
Okay.
And we're doing it on Friday.
Mm-hmm. Mm-hmm.
And then the sum of all of them.
Okay, I got it.
Can I sum just the rounded things?
Possibly.
Are
Okay.
you gonna have it done? Is the test made?
Uh-huh.
Are you done with my calc test thing? Can I take it?
Maybe. Possibly. Why do you want to take it on Friday?
Are you
It's
good?
fresh right now.
All right. Who has the answers?
I do.
Okay. Go, Marcus.
0.198.
When do you want to take
I
it?
did not.
No, I did not get
You
that.
did not get that.
Oh,
I
I
don't
got
trust
that.
Marcus.
Oh,
I
Okay.
got 0.354.
Sarah's up. Hold on.
What did
Go.
I do?
Yeah,
Point
that's what I got.
0.354. Got it.
The other ones.
Okay.
When are you taking it?
0.133.
Yep.
0.020.
Yep.
Can I take it
Point
today?
020. Okay.
And then 0.330.
Yes.
330. Okay.
No, I
That's what
didn't
Sarah
get that.
got.
And then the
Perfect.
sum,
Okay.
the sum of all those is 0.837.
And this is the other one.
Okay. So
So then we take the
those are
zero
the results.
back.
Hold on. Let's reconnect here.
Wait.
Those are the solutions for each row, and then the sum they said was 0.837. What is this number?
That is the sigma squared variance.
Which is the variance. Okay, so sigma squared, we got 0.837. It's not hard. It's the same process over and over again, but you have to be patient. It takes some patience. Then to find the standard deviation, last thing, we take the square root of that number, 0.837.
0.915.
0.915, perfect, or something close to that, right? If you're a decimal point off, that's fine. Like a thousandth of a whatever. 0.915 is the square root of that. Find the standard deviation. Those are going to be the doozies.
What am I?
I liked that one.
Plugging this into my calculator. What am I doing now? Because I got what Marcus got.
For the top one,
Yeah, Casey, did you not square it? Because I didn't square the
you
top
didn't square it.
What do you
The
mean?
group.
I just
You
did
type it in like this.
1.787
Watch.
times 1.1.
1.78, okay, parentheses,
Am I gonna have a
1.787
calculator for
minus
I
0
also
go
need one for the
parentheses
calc test.
squared equals that,
Steal
and then you times
I know,
Yeah.
but I don't know where they are.
0.111.
I'll look it up.
Okay.
Some of them are in here.
I know, and they need their
Yeah,
calculator.
I know, right?
Sixth period, yeah.
I'm in English.
Okay, one left. Are we ready for one more?
And it's
A big one, but-
Okay. All right, this is another doozy. The probability that a call received by a certain switchboard will be a wrong number is 0.02. What is that?
P.
We can call it P. You can call it Q. It doesn't matter. 0.02. Okay. Use the Poisson distribution. They're
No.
telling us to approximate the probability that among 150 calls.
N.
What's 150? N. Once you see it, write it down. Received by the switchboard, there are at least 2 wrong numbers. Okay, now here's the deal.
At least.
At least 2 wrong numbers. Yeah, you did it, right? Okay. All right, help you remember. At least 2 wrong numbers means 2 wrong numbers. or 3 wrong numbers, or 4 wrong numbers, or 5 wrong numbers, or 6 wrong numbers, or 7 wrong numbers, or 8 wrong numbers, or 9 wrong numbers, or 10, don't write this down, or 11 wrong numbers, or 12 wrong numbers, all the way up through
Find 0 or
150. Do you want to do all of those calculations and add them together? No. Hint, find the probability of 0 or 1 and subtract, right? The only way we're not going to get 2 wrong answers if I get 0 wrong answers or 1 wrong answers, right? Okay? So we're going to do those two and then add them together. So we've got to do probability of 0, and I'm going to go over here and do probability of 1. All right? The Poisson distribution was, this is a lot of work, P of x equals mu to the r times e to the minus mu all over r squared, or r factorial. Okay? That's what it looks like. We don't have a mu.
Yeah, we do.
N times P.
Yeah, we do. N times p. Mu is n times p, which is 150 times 0.02,
3.
which is 3 exactly. Hey. Boom. All right, so 3 is mu. 3 is mu. What is r?
R at 1
0. R is 0 for this problem, right? Times e to the minus mu, which is minus 3, all over 0 factorial. Okay, what's 3 to the 0 power?
1.
1. What's 0 factorial? 1.
1.
So all you have to do is calculate e to the negative third. 0.049. So there's a like a 4.9% chance. 0.05. 0.05. So that means there's a 5% chance that I'm going to get no wrong answers. Okay? 5% chance. Okay? Probability of 1, I do the same thing again. My mu is still 3 to the first power times
E to the negative 3.
e to the negative 3 all over 1 factorial.
So 3 times.
What's 1 factorial?
E?
1. So you don't have to divide by 1.
3 equals 0.145.
0.15?
Yep.
So what's the chances of me getting 0 or 1 wrong calls?
0.2.
20%. Okay? So what's the probability of getting 2 or more wrong calls? 0.05 plus 0.15 equals 0.20. Okay, that's probability. I'm not going to box that.
0.2.
0.20, right? 0.05 plus 0.15, we add those together? Okay, it's 0.20. Okay, so that means probability of more, 2 or, I'll say 2 or more. 2 or more equals
I have no way to read this.
80%.
0.80 or 80%. Okay? All right, those last two that we just did, those are going to be the hard ones. Those are the longest problems.
I'll do it.
Make sure if you're going to study 2 of them, study that one and the other one. I see a star next to Kelsey's like standard deviation one. I don't know if that means she's going to study it or look it over, but that would be a real good idea. Real good idea. Okay. Goodbye, people watching this video.
Can you give me my bag?